Good morning students. Welcome to 9th standard geometry lesson number 5 quadrilateral module 4. Just I am recollecting what we studied in the previous module. First one is the properties of parallelogram. There is opposite sides of the parallelogram are parallel and congruent, and opposite angles are also congruent. Second one, properties of rectangle. Opposite sides of the rectangle are parallel and congruent, and all angles are congruent. And diagonals of a rectangle are also congruent. And in the case of the square, the first property of square is all sides are congruent, all angles are congruent, and diagonals of a square are perpendicular bisectors of each other. And in the case of the rhombus, all sides are congruent and opposite angles are congruent, and diagonals of a rhombus are perpendicular bisectors of each other. Let's learn next type of the quadrilateral, trapezium. What is trapezium? When only one pair of opposite sides of a quadrilateral is parallel, then the quadrilateral is called trapezium. In this figure, segment AB and segment DC are parallel sides, and segment AD and segment BC are non-parallel sides. Therefore, ABCD is a trapezium. And in this figure, by property of parallel lines, angle A plus angle D is equal to 180 degree, and angle B plus angle C equal to 180 degree. And next is isosceles trapezium. What is isosceles trapezium? If non-parallel sides of a trapezium are congruent, then that quadrilateral is called an isosceles trapezium. In this figure, segment PS and segment QR are the non-parallel sides, and segment PS congruent to segment QR. Therefore, quadrilateral PQRS is an isosceles trapezium. And next is median of the trapezium. What is the median of the trapezium? The segment joining the midpoints of non-parallel sides of a trapezium is called the median of the trapezium. In this figure, segment AB is the median of the trapezium. Yes children, let's start your practice at 5.4. Question number 1. In trapezium IJKL, side IJ parallel to side KL, and angle I is equal to 108 degree and angle K is equal to 53 degree, then find the measures of angle J and angle L. First draw the trapezium IJKL, and in this question we have to find what is the measurement of angle L and angle J. And solution, first write given angle I is equal to 108 degree, and here it is given that side IJ parallel to side KL and side IL is the transversal. Then what about the angle I and angle L? Angle I and angle L are interior angles. You have already learned interior angles are supplementary. Therefore, angle I plus angle L is equal to 180 degree. Therefore, an angle I is given as 108. Therefore, 108 plus angle L is equal to 180 degree. Therefore, angle L is equal to 180 minus 108, that is equal 72 degree. Next, we have to find angle J. Here, first write what is given. Angle K is equal to 53 degree and side IJ parallel to side KL and side JK is the transversal. Then the angle I and angle K and angle J are interior angles. Therefore, interior angles are supplementary. Therefore, angle J plus angle K is equal to 180 degree. There is the interior angles, and angle J plus 53 degree is equal to 180. Therefore, angle J is equal to 180 minus 53 is equal to 127 degree. And last, your final answer, angle L is equal to 72 degree and angle J is equal to 127 degree. Question number 2. In trapezium ABCD, side BC parallel to side AD and side AB congruent to side DC, if angle A is equal to 72 degree, then find the measures of angle B and angle D. Here first draw the trapezium ABCD, and AB and CD are congruent is given, and angle A is also given, that is 72 degree, and in this question we have to find angle B and angle D. Solution. And first do the construction. Draw the segment BP perpendicular to side AD, there is A dash P dash D, and segment CQ perpendicular to side AD, there is A dash Q dash D. And what is angle A is given? 72 degree. Angle A is equal to 72 degree. And in trapezium ABCD, side BC parallel to side AD and side AB is the transversal. Then what about the angle A and angle B? And angle A and angle B are interior angles on the same side of the transversal. You have already learned the interior angles on the same side of the transversals are supplementary. Therefore, angle A plus angle B equal to 180 degree. Angle A is given as 72 degree. Therefore, 72 plus angle B is equal to 180 degree. Therefore, angle B equal to 180 minus 72, that is equal 108 degree. And next we have to find angle D. First I am considering the triangle BPA and triangle CQD. There is in triangle BPA and triangle CQD. First write the congruent parts. There is angle BPA congruent to angle CQD. There is each angle is of measure 90 degree. And AB and CD are congruent is given. In this triangle, these two sides are the hypotenuse. There is hypotenuse AB congruent to hypotenuse DC. And third one, segment BP congruent to segment CQ because of the perpendicular distance between the two parallel lines. By which test these two triangles are congruent? By hypotenuse side test, triangle BPA congruent to triangle CQD. If the triangles are congruent, then its other sides and other angles are also congruent. Therefore, by CACT, angle BAP congruent to angle CDQ. That is, BAP means angle A and CDQ means angle D. Therefore, angle A congruent to angle D. Angle A is already given 72 degree. Therefore, angle D is equal to 72 degree. And your final answer, angle B is equal to 108 degree and angle D is equal to 72 degree. Question number 3. In trapezium ABCD, side BC less than side AD and side BC parallel to side AD, and if side BA congruent to side CD, then prove that angle ABC congruent to angle DCB. The figure is already given, the trapezium ABCD. And here AB and CD are congruent is given. And here in this question, we have to prove that angle ABC. That means this bigger angle. Angle ABC congruent to angle DCB. Solution. First write given. Side BC less than side AD and side BC parallel to side AD and side BA congruent to side CD. And to prove that angle ABC congruent to angle DCB. Then first do the construction. Draw segment BP perpendicular to side AD, that is A dash P dash D, and segment CQ perpendicular to side AD, this is A dash Q dash D. In this trapezium, we have to prove that angle ABC congruent to angle DCB. And first I am considering the two triangles. There is triangle BPA and triangle CQD. First write the congruent parts. Angle BPA congruent to angle CQD, that is each angle is of measure 90 degree. And hypotenuse BA congruent to hypotenuse CD, that is already given. And segment BP congruent to segment CQ, there is perpendicular distance between the two parallel lines. And by which test these two triangles are congruent? By hypotenuse side test, triangle BPA congruent to triangle CQD. Therefore, by CA, which sides and which angles are congruent? By CACT, angle BAP congruent to angle CDQ. That is angle A and angle D are congruent. Therefore, angle A congruent to angle D. That is the equation number 1. And now I am taking side BC parallel to side AD and side AB is the transversal. Therefore, what about the angle A and angle B? Angle A and angle B are interior angles on the same side of the transversal. You have already learned interior angles on the same side of the transversals are supplementary. Therefore, angle A plus angle B equal to 180 degree. That is the equation number 2. And now I am considering the parallel lines side BC parallel to side AD and side CD is the transversal, and therefore angle C plus angle D is equal to 180 degree. That is equation number 3. The two angles are also interior angles. And from equation 2 and equation 3, angle A plus angle B is equal to angle C plus angle D. From equation 1, angle A is equal to angle D. Therefore, I am rewriting the equation angle A plus angle B equal to angle C plus angle A. And eliminating angle A, therefore angle B equal to angle C. Therefore, angle B means angle ABC congruent to angle DCB. Children, this is the midpoint theorem. There is the theorem of midpoint of two sides of a triangle. What is the statement? The segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it. That means in the triangle ABC, here it is a triangle ABC, P and Q are the midpoint of the two sides, and we have to prove that PQ parallel to BC and PQ is equal to half of BC. First write given. In triangle ABC, point P is the midpoint of segment AB and Q is the midpoint of segment AC. And to prove that segment PQ parallel to segment BC and PQ is equal to half of BC. And first do the construction. Produce segment PQ up to the point R such that PQ is equal to QR. and draw the segment here RC. This point, this line segment you have to join. That is, draw the segment RC. And the proof. First I am considering the two triangle. In triangle AQP and triangle CQR, which are the congruent parts? Segment PQ congruent to segment QR, that is by construction, and segment AQ congruent to segment QC, that is already given, that is Q is the midpoint, and angle AQP congruent to angle CQR. Therefore, by which test these two triangles are congruent? This is the side, angle and side. Therefore, by SAS test, triangle AQP congruent to triangle CQR. And triangle AQP congruent to triangle CQR. If the triangles are congruent, then other sides and other angles are also congruent. Therefore, angle PAQ congruent to angle RCQ by CACT. This is the equation number 1. And segment AP congruent to segment CR by CACT. That is the equation number 2. And from equation 1, there is angle PAQ congruent to angle RCQ. If these two angles are alternate angles are congruent means the lines are parallel lines. Therefore, line AB parallel to line RC. And from equation 2, segment AP is congruent to segment RC. And now segment AP is equal congruent to segment PB congruent to segment RC. And segment PB is parallel to segment RC. Therefore, PBCR is a parallelogram. That means opposite sides are parallel and opposite sides are congruent. Therefore, PBCR is a parallelogram. And therefore, segment PQ parallel to segment BC and segment PR is equal to segment BC. That is, opposite sides are, if this is on the parallelogram, therefore opposite sides are congruent. Therefore, PB/PR is equal to BC. And therefore PQ is equal to half of PR by construction. Therefore PQ is equal to half of BC, because since PR is equal to BC. That is, we proved PQ is equal to half of BC. Here, converse of the midpoint theorem. Statement: if a line drawn through the midpoint of one side of a triangle and parallel to the other side, then it bisects the third side. There is point D is the midpoint of AB and DE is parallel to BC. Then AE is equal to EC. That means E is the midpoint of AC. Let's move on your practice set 5.5. Question number 1. In the adjoining figure, points X, Y and Z are the midpoints of side AB, side BC and side AC of triangle ABC respectively. AB equal to 5 cm, AC equal to 9 cm and BC equal to 11 cm. Find the length of XY, YZ and XZ. Figure is already given. In this triangle ABC, X is the midpoint of AB and Y is the midpoint of BC and Z is the midpoint of AC. In this question, we have to find length of XY, length of YZ and length of XZ. Solution. First write given AC equal to 9 cm, AB equal to 5 cm and BC equal to 11 cm. And in triangle ABC, first I am taking these two side midpoints. Point X and Y are the midpoint of the side AB and BC respectively. Therefore, XY by the midpoint theorem, XY is equal to half into AC. AC already it is given, there is 9 centimeter, that is equal a half into 9, that is equal to 4.5 centimeter. Therefore, XY is equal to 4.5 centimeter. In triangle ABC, point Y and Z are the midpoint of side BC and side AC respectively. Therefore, by the midpoint theorem, YZ is equal to half into AB, that is equal half into 5 centimeter, that is equal to 2.5 centimeter. Therefore, YZ is equal to 2.5 centimeter. And next one is BC is equal to 11 centimeter, and point X and Z are the midpoint of AB and AC respectively. Therefore, XZ is equal to half into BC, that is equal half into 11 is equal to 5.5 centimeter. Therefore, your final answer, length of XY is equal to 4.5 centimeter, length of YZ is equal to 2.5 centimeter, and length of XZ is equal to 5.5 centimeter. Question number 2. In the adjoining figure, PQRS and MNRL are rectangles. If point M is the midpoint of side PR, then prove that first one SL is equal to LR and second one LN is equal to half of SQ. Figure is already given. The first bigger figure is the rectangle PQRS and smaller one is the rectangle LMNR. And M is the midpoint of PR is also given, and we have to prove that SL is equal to LR. And first write given quadrilateral PQRS and MNRL are rectangles and M is the midpoint of side PR. Then to prove, first one SL is equal to LR, second one LN is equal to half of SQ. And proof, quadrilateral PQRS and quadrilateral MNRL are rectangles. You have already studied all angles of the rectangles are 90 degree. Therefore, angle S is equal to angle L is equal to 90 degree. Here angle S and angle L form a pair of corresponding angles on sides SP and LM when SR is the transversal. Therefore, segment ML parallel to segment PS by the corresponding angle test. That is the equation number 1. And in triangle PRS, point M is the midpoint of PR and segment ML parallel to segment PS from equation 1. Then L is the point L is the midpoint of segment SR. That is equation number 2 by the converse of the midpoint theorem. Therefore, SL is equal to LR. Similarly, for triangle PRQ, this is a triangle PRQ, we can prove that N is the midpoint of segment QR. This is the equation number 3. And in triangle RSQ, from equation 2 and 3, point L and point N are the midpoint of segment SR and segment QR respectively. Therefore, Ln is equal to half into SQ by the midpoint theorem. Question number 3. In the adjoining figure, triangle ABC is an equilateral triangle. Points F, D and E are the midpoints of side AB, side BC and side AC respectively. Show that triangle FED is an equilateral triangle. Here figure is given triangle ABC, and this is the F, E and D are the midpoint of the side AB, side AC and side BC. We have to prove that triangle FED is an equilateral triangle. Then first write given triangle ABC is an equilateral triangle and points F, D and E are the midpoints of side AB, side BC and side AC respectively. To prove triangle FED is an equilateral triangle. And solution, then proof triangle ABC is an equilateral triangle. What is the properties of an equilateral triangle? All sides of the equilateral triangles are equal. Therefore, AB equal to BC equal to AC. That is the equation number 1 because sides of an equilateral triangle. Here points F and D are midpoints of side AB and BC respectively. Therefore, by the midpoint theorem, FD is equal to half into AC, that is equation number 2. And next is the points D and E are the midpoints of side BC and side AC respectively. Therefore, DE is equal to half into AB, that is the equation number 3 by the midpoint theorem. And next points F and E are the midpoints of side AB and AC respectively. Therefore, FE is equal to half into BC, that is the equation number 4. From equation 1, 2, 3 and 4, FD is equal to DE is equal to FE. Therefore, in this triangle FDE, FD is equal to DE is equal to FE. That means three sides of the triangle are equal. Therefore, triangle FED is an equilateral triangle. Question number 4. In the adjoining figure, segment PD is a median of triangle PQR. Point T is the midpoint of segment PD. Produced QT intersect PR at point M. Show that PM upon PR is equal to 1 upon 3. Hint is given here. Draw DN parallel to QM. Figure is already given. In triangle PQR, segment PD is a median of triangle PQR. And the point T is the midpoint of segment PD. In this question, we have to prove that PM upon PR is equal to 1 upon 3. Solution, then first write given. Segment PD is a median of triangle PQR. Point T is the midpoint of segment PD. To prove PM upon PR is equal to 1 upon 3. And then construction. Draw the segment DN parallel to segment QM such that P dash M dash N and M dash N dash R. Then prove. First I am considering the triangle PDN. Point T is the midpoint of segment PD and segment TM parallel to segment DN. That is already given. Therefore, point M is the midpoint of segment PN. That is by the construction. And therefore, the converse of the midpoint theorem, PM is equal to MN. In this figure, PD is the median of triangle PQR. Therefore, D is the midpoint of the segment QR. And in this triangle QMR, D is the point D is the midpoint of segment QR and segment DN parallel to segment QM, that is by construction. and therefore point N is the midpoint of segment MR by the converse of the midpoint theorem, and therefore Rn is equal to Nm, that is the equation number 2. And from equation 1 and 2, Pm is equal to Mn is equal to Nr. And now here PR is equal to Pm plus Mn plus Nr, that is because of P dash M dash N dash R. And from equation 3, PR is equal to PM plus PM plus PM. Therefore, PR is equal to 3 PM. Therefore, PM upon PR is equal to 1 upon 3. Thank you, dear students. To be continued.